Hello there. In this video lectures we will see the impulse, the momentum principle. The main purpose of this impulse and the momentum we are using to find out the field parameters like velocity, acceleration of a respective bodies. Because this comes to the dynamics. The dynamics, it's going to be always the force, mass, acceleration, it is going to be d. So what is the specialty in this impulse and momentum principle? So in this case what will happen? We need to define what is the impulse. The impulse is nothing but a large force is going to be acting in a short span of the time. Right? A large force acting on a short span of the time. The best example, I hope you know these examples of this one. That's going to be, suppose a cricket batsman is hitting a ball. So then what will happen within the short time, within the instant of the time, he is giving a large force to that ball. So that's why the ball is going to be moving towards the boundary or away from the batsman. Right? So these are going to be called the impulse. Thus we are going to say the force into the time I am going to be say the impulse. Then what is the momentum of the principle? So the momentum of the principle always we are going to be taking the mass into the velocity. Right? So that I am going to be taking mass into velocity. Right? By combination of these two, how we can write that equation? Right? To combination of this one, we are deriving the part of that by using the Newton's second law. What is the Newton's second law? F is equal to m into a. It means that the body is going to be subject to the applied force F. The direction of that body acceleration or the direction of the motion or the acceleration of the body is towards the direction of the force. This is what we have learned. So then in this case what will happen? How we can derive this part? There you can see the F I am going to be taking, this is the assume there is a large force is going to be acting. And further simplification, dv by dt I am going to be considering here. Right? So then I am going to be simplifying this equation. F into dt is equal to m into dv. Right? So then in this case, which is the variable in this case? dt and the dv is there. I am going to be taking the integration 1 to 2. So that means two positions I am going to be considering. If I am going to be taking this one, I am going to be getting f into t2 minus t1, that is equal to m into v2 minus v1. Right? And this terminology we are going to be called impulse. And this terminology we are going to be calling the momentum. Right? In this case also there we can see what exactly we are calculating from this part. Right? So from this part we are calculating the velocity of that object or the time how much it has taken. If other parameters are available, we can find out how much force it is going to be acting on that system. Right? This way we are using the dynamics to find out the different field parameters of the body. I hope you are able to understand this concept. Right? So this is going to be very simple concepts, one should get it easily. Right? You people also study at your intermediate also regarding this. So thank you for better understanding. So one should have to follow the sequence of video lectures so that the understanding capabilities are going to be improved little better. So thank you. After the discussion of impulse as well as the momentum of an object, now we are going to be trying to discuss about the principle of conservative of the moment. Right? So in this case what will happen? Conservation movement means when the object is going to be trying to move from position 1 to the position 2 like this. Alright? So this is going to be your object or the particle I am going to be saying. It changed from position 1 to the 2. Right? And then in this case what will happen? We are going to be considering its moment. What is the formula for the moment? Already we told that is going to be mass into velocity. And for this one, the moment, the initial momentum of the particle at position 1 is equal to the final moment at the position 2. By equating these two, we can find out the different parameters. So in this case, what is the initial moments we are going to be taking? That's going to be m into u1, right, plus m into u2, that is equal to the mass again the initial velocity of that particle and mass into the final velocity of that particle. There we can see what is the initial moment and the final moment. There we can see when it is going to be starting over here, so then it has its own initial velocity. At the same time, at the position 2 also have its initial velocity. And similarly, for the final velocity, that means final velocity at the position 1 and the position 2 also we are going to get. So then these equations we are going to be called the principal law of conservation of moment. And mostly we are using in the dynamics to find out the velocities at the initial position and the final positions we are going to be calculating. Thank you.